Hello everyone, this is Dr. Fan. If you like football, have you ever wondered the longest football throw? Or if you like soccer, what is the longest soccer kick? This is actually a classical physics problem, and let's dig into it today. So we can simplify the longest kick or the longest throw into this physics question. So let's say a player tries to throw the ball or kick the ball with the maximum speed. And if we ignore air resistance, what determines the range of the ball is basically the launching angle. In other words, we simplified the longest range into a question about launch angle. We know when a ball was thrown or kicked into air, the ball is basically going to follow a projectile motion. And we know that if we have the initial velocity of the ball v0, we can decompose the initial velocity into its horizontal component v0x and its vertical component v0y. And along the horizontal direction, we know the ball has constant velocity motion. In other words, my range dot x equals to vx times t. And because it's constant velocity, I know my vx equals to v0x. So my range is basically v0x times t. And from the launch angle, I can actually find my horizontal velocity. So how to find my initial horizontal velocity? If I change the color to blue, if let's say the launch angle is theta, we know my initial horizontal velocity equals to v0 times cosine theta. So if I substitute this value into my initial equation, my dot x equals to v0 cosine theta times t. And v0 is null, theta is null. As long as I know t, I can find my range. So how to find the time of the ball in air? We actually discussed this question in our previous video. Because in this specific situation, we know the initial velocity and we know the angle, so we can use the vertical velocity to find out the time. And how are we going to do it? We know the initial vertical velocity is v0y, which is v0y equals to v0 times sine theta. We know that. But we also know at the peak, the vertical velocity becomes 0. So we know the vertical velocity at the peak is 0. If we use this kinematic equation, Vy equals to V0y plus at, we can actually find out the time. So if we assume going up is my positive direction, then this equation becomes 0 equals to V0 sine theta minus gt. Because along the vertical direction, it's constant acceleration, and the acceleration is minus g. So I can find my time from this equation. So my time equals to v0 sine theta divided by g. So this is the time from the launch point all the way to the peak. Because we need the time from the launch point all the way to the landing point. So the time should actually be 2 times of this time going up, because the time going up and the time going down is the same. So I can see that my time basically is 2 times v0 sine theta divided by g. So now if I substitute this time into my equation here, what do I get? So my range dot x would equals to v0 cosine theta times 2 times v0 sine theta divided by g. So if I simplify this, I get v0 squared divided by g times 2 times sine theta times cosine theta. And if you remember what you learned in trigonometry, you can simplify this. So this, your range can become v0 squared divided by g times sine 2 theta. This equation is actually very important because it tells you your range is only going to be determined by your initial velocity and the launch angle. So if a player threw the ball with the maximum velocity he can, so this initial velocity is fixed. So the launch angle actually determines the range. And we know from trigonometry, the largest value for a sine function is 1. So when 2 theta equals to 90, my value here, sine 90, is 1. That is, this term becomes the largest, it becomes 1. In other words, if my theta equals to 45 degree, because 2 theta equals to 90 here, then I'm gonna have my longest range. So my range would become V0 squared divided by G, because sine 2 theta is 1. So that's the longest range the ball can reach if you threw the ball at exactly 45 degrees. Of course, in this situation, we ignored air resistance. If you consider air resistance, the optimal angle would be around 38 or 40 degrees. As a matter of fact, if your launch angle is closer to 45 degrees, the ball would gonna be further. For example, if you threw the ball at 50 degrees compared to 60 degrees, 50 degrees gonna have a longer range than 60 degrees because it's closer to 45 degrees. I actually have done some research, and online I found out the fastest record speed for a football that has been thrown. So it's ranged from 62 miles per hour to 75 miles per hour. So if we take a value in the middle, let's see the largest speed or the largest initial velocity of a football, let's see, is 65 miles per hour. If we convert this to meter per second, it's roughly 29 meter per second. Then we can use our equation, dot x equals to v0 squared divided by g times sine 2 theta. If we assume the football player threw the ball at the best angle, which is 45 degrees, so then the range would be maximum, which equals to v0 squared divided by g. If I substitute this value, which is 29 meter per second squared divided by 10 meter per second squared, then roughly I'm gonna get 84 meter. If I convert this into yard, it's about 92 yards. I have done some research, and the research shows in the NFL history, the longest range is about 80 yards or 87 yards, which is very close to our calculation, which is 94 yards, which shows physics do work. Lastly, let's look at the question I have left in the previous video. With the information and the equation, we know this question should be very straightforward. So the question says, a ball is kicked into the air under the same speed at 3 different launching angles. At what launching angle the ball can travel the furthest? We know that theta equals to 45 give us the longest range, but also we know if you are closer to 45 degrees, you're going to have a longer range. So if we consider 40 degrees, which is 5 degrees away from 45, and if we consider 55 degrees, the difference, let's say the difference is 10 degrees. And for 40 degrees, the difference is 5 degrees. And for 60 degrees, it's 15 degrees away from 45. And we know the closer to 45, the longer the range. So in other words, we know the range through at 40 degrees would be longer than 55 degrees, would be longer than 60 degrees, because this guy is the closest to 45 degrees. And this concludes everything I want to discuss. Hopefully this video shows you that we can use the launch angle to find out the maximum range. Thank you for your attention. I will see you next time.